Okay, so we have seen in the previous class how the elements from group 1, 2, and 3, the metals from group 1 and 3 loses the electrons from their valence shell to become a positively charged ion. Group 1 elements form a cation with a +1 charge. Group 2 elements, metals form a ion with a +2 charge, and group 3 metal forms cations with a +3 charge. In the similar manner, the non-metals from group 5, group 6, and group 7 gain the electron in their valence shell to complete their outermost shell, to have an octet in their outermost shell, and as a result, they become an anion. So group 5 elements, the group 5 non-metals, gain 3 electrons as they have 5 electrons in their valence shell because they are in group 5. So they gain 3 electrons and form an anion with a 3 negative charge. Group 6 non-metals gain 2 electrons in their valence shell to complete their octet and become an ion of 2 negative charge. And group 7 elements gain 1 electron in their valence shell to form an anion of -1 charge. So when those ions are formed, these ions, the positive and the negative ions, start attracting each other, and as a result, they are going to develop a very giant structure in which there are millions of positive ions and the negative ions at alternate positions, and as a result, an ionic substance or the ionic lattice is formed. Okay, so when we talk about these ionic compounds, normally these ionic compounds have a metal and a non-metal in it. Like, for example, if I talk about potassium oxide, so potassium is a metal and oxide is a non-metal. Its formula is K2O. Calcium sulfide, its formula is CaS, where calcium is a metal and a sulfur is non-metal. Aluminium oxide, where oxygen is a non-metal and aluminium is a metal. But there are few compounds which have ammonium ions in them. See, in ammonium ion, there is a nitrogen and hydrogen, both are non-metal. So the compounds of ammonium, all are ionic, although they do not have any metal in them. So this is an exception. Okay. So like ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium phosphate, all are ionic. But if you see, you will not going to find any metal in them. So this is the exception as well. So mostly in an ionic compound, there is a metal ion and a non-metal ion, but there are few compounds which are ionic which do not have any metal in them. Is this clear? Yes, Khatija?
Yes, sir.
Okay, complete this quickly. Today is 3rd of October, right? Done. Okay. Khatija, are you done as well?
Yes, sir.
Okay. So more about that. So see, look at this periodic table and try to understand this. Do you guys have a periodic table? Do you have a just Khatija? Do you have a periodic table with you?
Yes.
Okay. You keep it with yourself and paste it in your copy. Okay. So it means that you always have a periodic table with you. So see over here. Whenever there is a metal from a group 1, which I highlighted with the red, having all have a plus one, they all form a plus 1 ion. The one which are in group 2 will going to form a plus 2 ion. The one in the group 3 from aluminium will going to form a plus 3 ion. In the same way, group 5, the highlighted one will form minus 3 ion. The group 6 will form minus 2 ion, and group 7 will form minus 1 ion. So you can put these charges over on the above with the pencil, so it would be easy to recall. Sorry? No, not necessary. Okay. Now, the thing is, okay. Okay. So, if you see, as you have mentioned the chart on above the group number, right? So it means that by looking at the periodic table, you can easily able to figure out the charge of calcium. That is, it is going to be form a plus 2 ion, right? You can mention these charges over here on the top. Okay. For gallium, I can say it will be plus 3 ion. For bromine, it will be minus 1 ion, right? For sulfur, it will form sulfide ion minus 2. Okay. Now, if we talk about these one, so the one which I highlighted with the orange have a variable charges. And if you see on the top, there is no group number, right? There is no group number on the top. So how could you able to identify their charge? Yes, Manahal.
It will be given.
It will be given with the name. For example, see over here, I have written iron 2 ion. So this 2 in the Roman written telling me that in this case, the iron is forming a 2 plus ion. The iron here is forming a 3 plus ion. Copper is forming a plus 1 ion. Copper is forming a plus 2 ion. Manganese is forming a plus 2 ion because 2 in the Roman is written. Is this understandable? So, but still you are left with these three: zinc, silver, and scandium. When their name is written, they are not going to mention the atomic number, the charge in the Roman for these three. So you, for these three, you have to memorize it. Beside these three, rest of the one you got from the periodic table, and the remaining one you got the number in the written in the Roman in the ion. Okay, so for these three you have to memorize. And if we talk about scandium, it is not that much important, but these two are very important. So you have to memorize that whenever the silver in the compound, it have a +1 ion, and whenever there is a zinc in the compound, it is in the form of a 2+ ion. Is this clear? Okay.
Yes, sir.
So just more after putting them more about ions, just note down this. Done? Yes, Khadija, are you done as well?
Yes, sir.
Okay. So now the electronic structure for these. So if you see, when we have to draw the electronic structure of the ions which have an atomic number lesser than 20, we usually form the all the shells which are present in the ion and all the electrons that are present in the ion. Okay, but if you have to draw in case the electronic structure for the ion whose atomic number is 20, whose atomic number is greater than 20, and it is a cation, so it is the very easy practice for them. You have to do it like this only. If you look in the periodic table, you will find that the atomic number of copper is 29 and iron is 26. Right? So if you have to draw the cation which have atomic number greater than 20, you have to just put the symbol in the middle and an empty shell and then close in the square bracket and put the charge as a power. That's it. Is this clear? Yes. Okay,
Yes.
do it quick. Done. Yes, Khatija.
Yes, done.
Yes, Manahid. So now, if we have to draw the anions with the atomic number greater than 20, we will draw in this way. That we know that when and what anion do anion gain the electron. So when it gain the electron, after gaining the electron, it will have 8 electrons in its outermost shell. So we will figure out from the periodic table that how many electrons it is going to gain. For example, if I talk about bromide, so if you see bromine is in the group 7, having a -1 charge, which means when it becomes an anion, it will gain 1 electron. So, and we just draw its outer shell, okay? And in outer shell, the 7 electrons with the same cross, which means that these 7 electrons belongs to bromine, and 1 electron with a dot, which means this is the electron which it gained. Is this understandable? For example, if there is a confusion, have a look over here. Let me talk about phosphide. Phosphorus is 15, right? And when it becomes phosphide, if you see, where is phosphorus in the periodic table? Yes, in group
5.
5. So how many electrons it is going to gain?
3.
3. It have a 5 electron in its valence shell, as its group is 5. So to make the 8 electron in its valence shell, it will gain 3 electron, right? Okay. So if you have to draw the valence shell in that case, you have to just draw only a shell like this. We know that it have a 5 electrons, so we'll draw these 5 electrons like this. And when it becomes ion, it gains 3 electrons, so we put 3 dots to show that these 3 electrons are gained, and then enclose in the square bracket and put a 3 negative charge. Is this understandable?
Yes.
Yes. Okay. So do this example quickly. So till here, you have to remember the charge for 2 ions. One is zinc, which always got a +2 charge, and the other one is silver, which forms a +1 ion. Rest of the ions, we got their charges by the help of the periodic table, so there is no need to remember them, right? Then? Yes, Khatija? But now what I'm going to share you few more ions, which we call them polyatomic ions. Why they are called polyatomic ions? Because they are made up from by the combination of 2 or more elements. And you are not going to find these ions in the periodic table. So it means if these ions are not in periodic table, you have to remember the formula as well as what charge they carry along with the name, right? So those 2 ions, the zinc ion have a +2 charge, you have to memorize that. Silver ion have a +1 charge, you have to memorize it. And these are, I think, 12. So you have to memorize them as well. Okay. So what are polyatomic ions which have more than one element? Like if you see, I'm saying ammonium ion. So it is a combination of 1 nitrogen and 4 hydrogen. So you're not going to find it in the periodic table. Is this understandable?
Yes.
Yes. Okay. Keep this as capital in uppercase. Now, how we will draw the electronic structure for these ions if it is asked. It is going to be same like the cations having the atomic number greater than 20. We will draw it like this. Okay. So here I made this table. Okay. Is everybody completed till here? Yes,
Yes,
Khadija? Okay. So to identify the names of anions, whenever a cation will form, there is no change its name. For example, sodium is an atom. When it becomes ion, we call it sodium ion. It's a cation. Aluminium is an atom. When it becomes +3, we call it aluminium ion. Okay. But when the anion is formed, when they gain electron, the last part, the suffix of the name is replaced by these three terms. For example, it is what we call it chlorine, right? But when it get a negative charge, now instead of chlorine, I will use chloride. For example, it is S for
sulfur.
sulfur. When it becomes 2 negative, then I will call it
Sulfide.
sulfide. But when it becomes SO3 with a 2 negative, then I will call it sulfide. And when the sulfur bonded with 4 oxygens with a 2 negative charge, then I will call it sulfate. Is this understandable? In the same way, when I talk about nitrogen with a 3 minus charge, nitrite. Nitrogen with a 2 NO2 with a -1 charge, nitrite. NO3 with a -1 charge, nitrate. So you have to the one which I highlighted with the green are the ones which are polyatomic. So you have to remember these. Is this clear?
Yes.
Okay.
Sir,
Yes.
I have a question that when we are drawing the electronic structure for the polyatomic ion, so this if it is a anion, so we have drawn it. But if it is a ammonium, so the same structure will be drawn for the ammonium.
Yeah, it will be like this only.
Okay. Thank you.
Okay. Miss Khatija, are you done as well?
Yes.
Yes, Janam? Okay. Okay. Now, the next part is writing the formula. How we will write the formula of ionic compound. So, look at these three cases. There are two rules by which we can make the formula. One is when the cation and anion have a same value of charge. Obviously, the charges are not same because one is positive, one is negative, but the value of the charge must be same. For example, when we talk about aluminium phosphate, we find aluminium in the periodic table. You will see it's in group 3, so that's why I put a +3 charge. Okay, and phosphate is the polyatomic ion which I have to remember, and it got a 3 negative charge. So when both the charges, both the ions have a same value uh, of a charge, then what we do, we just join them, and that will become your formula. Okay, just listen the next instruction. After completing this, have a look at the next rule. They are saying if the value of the charges of cation and anion is different. So I want you that the first case is aluminium hydroxide. So you just put the ions like this for the last three at the bottom, okay? After writing the names, you need to put the formula of the ions like this below the names of these, okay? So you can take the help of the periodic table and the polyatomic ions that you have noted down. of the second rule, then write down the names of these three compounds, and then beneath them write the formulas of the ions as we have done like over there separately. Okay. Replace this. Lost. Yes, Khadija, are you done?
So I'm on in the last part.
Okay. Sorry. Of the ions, not
We're
the
done.
whole compound. Okay, just write the formula of the ions. Good. It's ID, right? So you will find it in the product table because it's a ID tells us that it's a single ion, it's not a polyatomic. And ID and AD tells us that it's the polyatomic, so you will take the look at the list. Did you find hydroxide? No. Yeah. Yeah. Did you find via? Good. Ms. Khatija, are you done with the name formulas as well? Formulas of the ions?
Yes, sir.
No, don't do this. I just want you to put that because this is the second way. So I'm going to tell that, but just first put the formula of the ions. What is it? Iron 2, which means iron have a. Yes. I what is the symbol of iron? Fe. Bromide. Yeah. Why -2? It's group 7. Group 8 are all completely filled. So it's -1. +2, +3, -3, -1. Okay, do the last one. It's magnesium phosphate. Okay, now, now how will you make this formula? Do you have one idea? No. It's 18. It's a polyatomic. So, Okay. Is everybody there? Okay.
Yes.
Now, when the value of the charges are different, then we do this thing. See, we shift the value to the subscript of the opposite ion. What is the value of this charge? One value is 1. So I will move 1 over here. That's why there is no need to put a 1 over here. The value of this charge is, this ion is 3. So I will move 3 in the subscript of this. And as, listen, there are 2 atoms. So that's why I have to enclose it in the bracket. If I instead write it like this, then it means that 3 is with the hydrogen only. Okay, so there are 2 atoms, that's why I have to enclose it in a bracket. See, in the next case, the 2 moves to the subscript of Br and 1 moves to the subscript of Fe. In the third case, the 3 moves to the subscript of Mg and 2 moves to the subscript of PO4, as there are more than one atom, more than one element. So again, enclose it in a bracket and put a 2. Is this understandable?
Yes, sir.
Okay, that's. So now you guys understood how to write or how to make the formula of an ionic compound.
Yes.
Is there any doubt?
No.
Sure.
Yes.
Okay. So have you all noted down the formula?
Yes.
Okay. So this is the task. Do it quickly. I will become maximum 5 minutes by having prayers. Till then, you guys.
Sir?
Yes, how many are done?
We're done. All.
Okay, 4. Yes, Khatija?
We're done all.
You have done all. Okay, good. What about you, Manahil? Okay. What formula you got for aluminium oxide? Aluminium oxide. Okay, yes. Very good. So, if you see, aluminium is in group 3, got a 3 positive charge, and oxygen is in group 2, got a 2 negative charge. So, it will be Al2O3. Okay. So, the one which left, okay, Khatija, you can WhatsApp me, and you both, what you will do, just note down all the names and do it before tomorrow's class, okay?
Sir,
Yes.
can you please explain once again the naming criteria, the table which you have shown earlier?
Yeah, sure. Whenever there is a negative ion with a single element, with the exception of hydroxide, the suffix of the name is replaced by IDE, okay?
Okay.
And if there is a non-metal bonded with the oxygen and forming a negative ion, then the suffix is replaced by ITE or ATE. The one with the lesser oxygen is ITE, like SO3 minus, and the one with the more oxygen is ATE, like SO4 minus is sulfate, and SO3 minus is sulfide. In the same way, NO2 minus 1 is nitrite, and NO3 minus 1 is nitrate.
Okay.
Is this clear?
Yes, sir. Thank you.
You're welcome. If you just WhatsApp me, and if you are done, you can leave. And you guys just note down all the names. Done? Okay. And complete it before the class, before next class, so I will check it in the next class.
Allah Hafiz, sir.
Allah Hafiz. Yes.